Alright, so let's look into this question called rotation of array, which is b times. So array rotation and array reversing are two different terms and two different approaches as well. So do not confuse with those things. So let's understand the question first. Okay. So let's say you are given an integer array called a and its length is 5, so n is 5, and b times I need to rotate. So b defines how many time rotation looks. So let's look how when I attempt to rotate our array first time, very first time, how does it looks like? Okay, so rotation says the first time it says 5, 1, 2, 3, 4. So this is nothing but I'm pushing my last element to the first and my remaining elements 1, 2, 3, 4 to its right. This is what I'm doing, right? I hope it's making sense. Second time if I do my array rotation, then I'll do the same logic. My last element will be put to the very first index of the array, and the remaining elements will be pushed to its right. Okay, before pushing this last element to the first, you have to make sure these are coming to its right. I mean, that's the concept. Okay, so when you are going from second time, so second time, how does the output looks like? 4, 5, 1, 2, and 3. I hope you're getting it. Now when you're pushing the third time, the third time rotating the array, the output looks like same thing. 3 will be pushed to this, the remaining elements will become to its right. Okay, so it looks like 3, 4, 5, 1, and now this is the output you need to return. This is what it's expecting. So after you rotate 3 times your given array, it should something looks like this. Okay, so let's look into this brute force approach first. If I go with brute force approach now, what are you going to do? So what's the idea? So definitely let me make it picturically defined so that you will be understanding this. Let's say I have an array called a again. This is how the array looks like in pictorial mode. 1, 2, 3, 4, 5. Okay, something like this. So definitely what I'm going to do is I'll be removing my last element and I'll be pushing the remaining element to its right. That's the idea, right? So how will I do? So this last element I'll be storing in some variable called temp. Okay, because I'll be if I don't remove this element, how will I push the other elements? I need to vacant some place, right, to push one by one. Correct? You'll get to know what I'm doing. So this temp, what is the last element here? The last element is 5 here. Definitely I'll be removing the 5 and I'll be storing it here. Correct? 5 is stored here now this is empty. Now I can simply transfer each element from my given array to its right. Correct? Because if I transfer 4 here first time, right, if I transfer 4 here, now this is empty. Now I can transfer 3 also here. Right? 3 will come here, 2 will be coming here, 1 will be coming here, right? Now what is the vacant place now? The very first index. Finally in the end I'll be pushing my whatever I stored in my temp variable, that I'll be pushing to my very first index. Correct? That's what I'm going to do. 5, I'll store it. So this is what it looks in the very first time when you rotate the array. Okay, so when you do the second rotation, the same logic continues. It will store the last element in temp, which is 4. Correct? So 4 will be stored here, and now the one by one you will be transferring to the right. Correct? So if it is how defines is something looks like this: 5, 1, 2, 3. Now 4 will be transferred to the very first. Right? That's how it looks like. Third time when you do, it is something like the output will be 3, 4, 5, 1, and 2. This is the output. Correct? Now let's look the same thing whatever we have discussed now. Let me put it in code. How does it look in? So I'll just write a for loop that runs from 0 to n minus 1, not n minus 1, 0 to b, because how many times the array rotation happens, b will decide. I'll run from 0 to b, the first time, second time, third time. This will decide. This loop is going to decide it. And the second step I am going to do is the last element I'm storing in some temp variable, as I already mentioned about it. So temp will be stored In temp variable, I'll be storing my last element, which is n minus 1. Hope this is making sense, because n minus 1 is my last index element. I'm storing it here, right? I just told. Now, what is the third step? Third step is I'll be pushing all my elements to its right, because one place is empty now. I'll keep on pushing. So each element I need to go right. I need to go through each element and push. So definitely I need one more for loop for that. Okay. So if this is the case, let's say, how can I show it? Just focus on this. If this is the case, 5, 1, 2, 3. So what do you think I will be starting from? I'll be starting from here, right? This index, and I'll say go to right, and I'll come to this index now, and I'll say go to right, right? So from n minus 1 I'll be starting, correct? So my second loop runs from n minus 1 till 0, because from right to left I'm coming like this, right? From right to left I'm coming. So what I'm telling is, as I know my n minus 1 place is empty, because a of j is what? First I'll be starting with n minus 1. This is my last index. My last index is empty, so that empty index will store some element, correct? One by one. So now 3 will be coming here, correct? 3 will be coming here. 3 will come here. 2 will come here. 1 will come here, and 5 will come here, correct? One by one it has come. How it is coming? A of j is equals to, I'm storing simply my a of j minus 1 element. Hope this is making sense. Whatever the empty index, okay, that is storing your last previous element, that is a of j minus 1. All right. So this is what logic for transferring the element. Now at the end of this logic, you will say push your temp variable to your first index. How will you say? It's like again a of 0, because my first index is 0. Array starts with 0 index, you know that. So my temp, whatever the temp has, that will be stored to. This is the logic it will perform. So this for loop will perform, okay, for transferring, and this is for how many times you need to rotate. The first time you will rotate first time, and second time you will rotate again, third time you will rotate, and you will stop it when b is equals to 3. I hope this is making sense. Right, so this is brute force approach. And what is the time complexity for this? What do you think? Time complexity for this piece of code is b times you are running the array, first array, and n times you are running the second array. B into n, we go of b into n. Alright, so b into n is obviously a red flag, because we have more optimized code, I mean, for this as well. Let's say we cannot exceed 10 to power 8, right? That is what we have been doing since start. So definitely we have an optimized solutions for this as well, where we can reduce the time complexity. So let's look into the optimized solution now. I just wanted to help you understand how the set of observations looks like before solving this. So why this is optimized and how can we optimize? Okay, let's look into this set of observations. Okay, so let's say I have this array called, look into this, very focus into this, you will be getting the answer. 1 2 3 4 5 is my array. Okay, what if I reverse the array? Okay, as I discussed in the start as well, how reversing looks like, something like swapping 5 4 3 2 1. Simply swap the first with last, this with this, will be get your answer. Reversing, you know it very well, I believe. So you have reversed the array now. Now if you look into the output, okay, what is my output? This is my output. I should get 3 4 5 1 2. Okay, now focus on this. You have an given array, you are reversing first time, and if you check your reverse and output, these have some connection. Check the first 3 elements, 5 4 3, and check your output. Is it not somewhere matching? But it has been reversed, right? So when you pick your first 3 elements in the reversed array, and if you check your output, you are finding that is your answer, but in reversed manner, correct? Similarly, if you check your remaining elements in the reversed array and the remaining elements in the output array, that is also matching, but in reversed manner. Don't you think reverse is working here? Reverse is something the crack, and it's like the hack of this question. Okay, so I'll be writing a reverse logic. So definitely my answer is, from reverse array I'll be picking the B elements, because this 3 is nothing but my B, right? 3 times I'm reversing, rotating, correct? So my first 3 my like how many elements to pick, B will decide. The other elements I'll be deciding. Okay, so I am just reversing my first B elements. I'm getting my output, and the other elements I am just simply reversing, right? So what I'll do is I'll write a reverse logic first, because reverse. I hope to understand what reverse is doing. Okay, so let me write it first. So I'll write a reverse method that is accepting 3 arguments called start index, end index, and an array. So this is the whatever the logic I am going to write, that will reverse any kind of array with from from start index to end index. Whatever the index I'll be providing, based on that index it will be reversed. I guess you understand what reverse does. By the way, let's say to make you understand, let me help you with an example called I have a container called A that is having an orange juice. Okay, O, and I'm having one more container called this A container, this is B container. Here I'll be having some called apple juice. Okay, so what I'm asking you, the ask is, I want you to swap the juices between 2 containers. I want my orange juice in B container, I want my apple juice in A container. Okay, so how will you do? The answer for this, definitely you will take an help of an empty container called C. This is empty container. Simply, for the first time, you will transfer your orange juice to this C container. Now your orange will be coming here, correct? I hope you're getting this. Now A is empty, so definitely your apple juice will transfer from B container to A container, correct? Now apple will come here. Now B is empty. Now finally you will make a move of transferring your orange juice to B container, correct? Now orange will coming here and C is empty. I hope this is making sense. This is how you transfer, right? This is the logic for swapping. The same logic I'm going to apply. So this is basic example I've given to help you understand. To know about it, then well and good, all fine. I'll take a empty temporary array as I've taken the container, and I'll say A of start, whatever the A of start, transfer to temp. Now A of start is empty, so A of start I'll be storing A of end, and finally A of end is empty now. Now I will be transferring my temp variable to temp element to this. This is what you do, the same thing, right? And finally you will say don't stop. This is for first time you've done. You need to perform for set of time, right? Till your start is meeting end, correct? So start plus plus, end minus minus, because start is going from left to right, so it should move from like this, start plus plus, and end is something from right to left you're moving, it should come by minus minus. Okay, I hope you got this, but before that I forgot a step, which is a for loop. Let me bring it down. The same thing I'll be bringing it down. Okay, and I'll just add a for loop, nothing else, because you will be traversing, right, each array from start to end, right? So you will stop when start is equal to end, you will be stopping it. So this is the logic for what? Reversing it. Okay, you have written a logic for this. Now you will look to the optimized approach for this. I already told the observation is you need to reverse this array, right? So first time you will be doing what? You will reverse in this way, kind of what? So you will say reverse 3 arguments you need to pass: start, end, and array. Array is A only, correct? Start index. To reverse the whole array, what is going to be my first index? 0. What is going to be my last index? N minus 1. I hope you're getting it. 0 to 0 comma n minus 1. I hope this is making sense. The first time you're reversing the whole array, right? The second time we know the answer very well. I guess we discussed this to help you understand. Let me write this first. The first time you have reversed this array. Okay, the given array is 1, 2, 3, 4, and 5, and the reverse array is what now? 5, 4, 3, 2, 1. This is your answer you will be getting in this step. Okay, now the second time, what did I tell you? From your reversed array you will be picking the b element, b times the element, right? This is the answer in your, no, this is the output array, right? But you need to reverse this again. So you will be picking how many elements? B elements. But b is given, that many elements will be picking. So I am telling reverse the 0 to b times in the reversed array. Okay. In your reversed array now, you are reversing b times. So this is my reversed array. What is my b times if I reverse this 3 times? Like it will be like 3, 4, 5. I'll be getting, correct? 3, 4, 5, 2, 1. This is my output I'll be getting in the second step. Okay. So partial answer I already got. You can see this is matching, right? Now the remaining elements in reverse array, because this is not matching, right? This is 1, 2 and this is 2, 1. Again I will be reversing. Okay. Reverse b to n minus 1, the same array, correct? So b in the sense, now 0 to b is this, like b is 3 now, so you will stop. Now from 3 you are taking, like from 3 to this many times n minus 1. From b to n minus 1 in the sense what? From here to till last. That is the remaining element, correct? That remaining element you are reversing again to get the expected output. So finally your array will be looking at 3, 4, 5. This 2, 1 also going to reverse. So 1, 2. This is what it matching with the output. That is what we want, right? I hope this is making sense. And this instead of writing many times reverse code, I just written the generalized way to reverse. The same method I am calling it, I am just passing the arguments in different ways. What arguments should be passed is very important, because first time you are reversing whole array, I am passing 0 to n minus 1, because 0 to n minus 1 is something but the whole array. Second time I am passing till b times reverse, till b times, because b is 3 now, 3 times reverse. That is the that is the output matching 3, 4, 5. Finally the remaining elements. The remaining element is 4, 5. Like it is starting from b to n minus 1. B in the sense from b value till the last element, so n minus 1. That's why it is b to n minus 1. I hope this is making sense. Now you will be getting, and finally you will return your array, return a, because you are not using any extra array or extra space. So you are using the same array, and in that same array you are performing this reverse thing. Okay. And what do you think the time complexity for this? Time complexity is what here? What do you think? Big of n. You're running, for one time, right? Like, I hope you're getting it. The first time you reverse, you run from 0 to n, right? Only b times. And the second time you run again b to n minus 1. So some limited time. So let's consider n, 0 to n. The big of n times you're running. Time complexity is big of n. I hope this is making sense. And space complexity, you are not using extra space, so big of 1. I hope this is a what flag? Green flag. Green flag are our best favorite, right? So this is what the logic says for the question called rotating array b times. I hope this question made sense. The real-time application for this, where are you going to use it? This type of logics we're using it in gamings, because I guess you played online Ludo, right? Let's say 4 of us are playing Ludo. The first time the turn 1 will be assigning to player 1. Turn 2 will be assigning to player 2. Turn 3 will be assigning to player 3. Turn 4 will be assigning to 4. After turn 4, again it is going to turn 1, right? Player 1, right? So how this reversing occurs? This is the logic. There are a lot of applications. This is just an example of Ludo I've given, but a lot of examples. Okay, so a lot of applications we are using in gaming, animations, in Candy Crushes also. You have 2D matrices, transpose kind of thing we're doing there, reversing also. So I guess that's all making sense for solving this question. I hope doing good. Take care of yourself and stay tuned and stay in touch.